our objective for today, I can solve and graph absolute value, one variable inequality. Let's read it together. 1, 2, 3. I can solve and graph absolute value, one variable inequality. Okay? Yes, Cornell notes. And once again, we are on the same concept, which is one variable inequality. Okay? With this lesson, we're going to finish chapter 3 already. Okay? So we already know what one variable inequalities are. I gave you guys definitions. You don't need to write this down. You already have it. We gave you definition, examples, unexamples. We know our steps. Our steps are simplify, isolate, plot, and check. So by now you guys have this memorized, right? Okay. So you got your Cornell notes ready. And once again, our title was absolute value, one variable inequalities. Now, did you guys notice that on the papers that I give you, on the Cornell notes, I give you Cornell notes such as this, something like this. And here where the note section, I actually cut it in half. Do you guys notice that? Okay, do the same please right now. And what I need you to do right here, we're going to start on the left-hand side, write example 1. We're going to be doing the same thing that we've been doing. We're going to be solving, graph, check, and write your set notation. Okay, we're doing the same thing. Okay, but we're starting where? On the left-hand side. All the examples that I'm going to give you, guys, focus please. All the examples I'm going to give you, even when you check it, I want you to stay on the left-hand side until I tell you to write on the right. Right? Okay, so right now we're going to start on the left-hand side. Copy this down, please. Example 1. Absolute value, x minus 1, less than or equal to 2. Absolute value, x minus 1, less than or equal to 2. All right. Everybody look up, please. Just to clarify, when we talk about equations and inequalities, and right now I'm going to be talking about two sides of it. I'm going to have one side, which is the left side, and the other side, which is the right side. I meant to do that in blue. So in regards to the inequality symbol, everybody look up to the screen. We have a left side of it and a right side of it. Are we there? Okay. So when I refer to the left side, then you're looking over here. When I refer to the other side, I'm referring to this side. Okay, so here we go. So let's look at it. Do we have anything outside the absolute value on this side of the inequality? No. We have the absolute value, and there's nothing outside of the absolute value. Let's look at the right side. Can we simplify the right side anymore? No. So therefore, at this point, we're going to start our two inequalities. Right now, you're just paying attention. I'll give you time to copy. Here we go. Pay attention to this step, because this is key. If you don't get this step, you're probably going to get the rest of it incorrect. Everybody that's eyes on the screen. We know that this one will be our negative. So if this is a positive 2, that means I need to multiply times this negative to make it a negative 2. However, if I multiply times the negative when there's an inequality, what happens to the symbol? We change the symbol. This stays the same, so I'm going to rewrite that as x minus 1. And then from there, I'm going to write my positive side. The 2, it's a positive, stays a positive, so pretty much I rewrite everything. X minus 1 less than or equal to 2, the same, except for the absolute value symbols, right? Okay, copy that, please. All right, as you're finishing off these notes, check this out. I want you to write an asterisk, and let's do that. I'm going to do that in blue. Right above, right here, and write flip when, and then you write a negative symbol like this, and then just go like this, like that so that you can see the entire process from here when it becomes a negative, and then you flip the symbol. Does everybody see that? Okay, so that's just a little note so that you can remember. All right, let's continue. I think from this point we can do the rest of it together. So let's solve this one over here together. We have x minus 1. What is the inverse? Plus 1, and I'm doing that with green. We're left with x greater than or equal to negative 1. On the same token, let's solve this one over here, and I'm going to start with red. Same thing, we add 1, x is less than or equal to 3. Simplify, isolate, what's next? Plot. Let's plot this. Okay, and here's 0. I got negative 1 right here, and I got 3 over here. Okay, I'm going to graph the green one first. It says x is greater than or equal to negative 1. Greater than or equal to. Does it include negative 1? Yes, so I plot my point. There it is. And it says x is greater than negative 1. What numbers are greater than negative 1? Everything to the right. Right? Okay. Next, let's graph the second one. X is less than or equal to 3. Does it include 3? Yes, I plot my point. And it reads x is less than 3. Numbers less than 3 are to the left. Arrow at the end. Who noticed that both of them are intersecting? And from the previous lesson, we know that this is a compound inequality and is an and. Label that. Bam. All right, here we go. So let's check this. So we got simplify, isolate, plot. Let's check. I'm going to write check over here at the top. Check. I'm going to do that in black. I'm going to rewrite the inequality symbol. I mean the absolute value. Absolute value, but instead of x, I'm going to open up a parenthesis. A parenthesis. And then minus 1. Close the absolute value, less than or equal to 2. So now let's look at our solution set right here where both graphs intersect. What would be the easiest number to use? 0. Does everybody see that? Yes. Yeah, so I substitute in here 0. What is 0 minus 1? Negative 1. And I bring down the absolute value symbols, the inequality, and 2. From there, what is the absolute value of negative 1? Positive 1. Less than or equal to 2. Is 1 less than or equal to 2? Yes. So pretty much, yes, our solution set is here. Okay. Now, at this time, we need to write our inequality. One inequality for this whole thing. Check this out. The easiest way of doing it, pens down really quick, eyes up here. If we look up, since this is an and we know it's a compound inequality, this is the easiest way of writing it. I'm going to write my extremes first, negative 1 and 3. What variable are we using? X. And let's see. What are these numbers compared to negative 1? Right? All these are greater, which means negative 1 is less than that. Is that correct? Does it include the negative 1? Yes. Okay. There's an equal sign right there. And what are these numbers compared to 3? Less than. Does it include 3? Yes. So therefore, that's my inequality. And from there, check this out. The set of all x such that, okay, there's my inequality, and then we close our set. Copy that, please. All right, so let's continue. Now that we have our solution set, let's go to number 2. Write this one right underneath that one, example 2. We're still on the left side. Here we go, example 2. Absolute value of x minus 3 less than negative 1. All right, let's do this one together. Let's see. Do we have anything outside the absolute value? Yes, what is it? A negative 3. So the inverse is to add 3 to each side. We're left with absolute value of x less than 2. Do we have anything else outside the absolute value? No. Can I simplify this side? No. So at that point, we're going to write our two inequalities. I'm going to write this one in red, the one for the negative. So 2 times the negative, that's negative 2. And if we multiply times the negative, what happens? We flip the inequality symbol. And what's inside the absolute value? X. Okay, and over here I'm going to write a plus, and it pretty much stays the same, x less than 2, but without the absolute value. Okay, simplify, isolate, plot. Now let's plot. Okay, we got, is that a little crooked? Yeah, it is. There it is. We got 0, negative 2, and 2. I'm going to graph this one in red. Do we include negative 2? No, so it's an open circle just to indicate our spot. And it reads, x is greater than negative 2. What numbers are greater? Everything to the right. Right? This one, does it include the 2? No, open circle, just to indicate our spot. And then x is less than that and everything to the left. Once again, do they intersect? Yes. So this is an and. Let's check it. Let's rewrite this. This is absolute value, open parentheses, close absolute value, minus 3 less than negative 1. So by looking at it, which will be the easiest number to substitute in there for my solution set? 0. Absolute value of 0 is 0. So pretty much this cancels, and we're left with what? Negative 3 less than negative 1. Is negative 3 less than negative 1? Yes. Okay. All right, let's write our inequality since this became a compound. So I write my extremes, negative 2, 2. We're using the variable x. So let's see. Negative 2 is less than all these numbers. Is that correct? And x is less than 2. Okay? And then I just write my solution set of all real numbers, x, such that, and we're done. All right. And the last one on the left-hand side. Copy this one down, please. If it doesn't fit in the front, turn your page over, but stay on the left-hand side, please. Copy this one. Absolute value of x plus 3, and then outside of the absolute value is minus 4.5, less than or equal to 7.5. See if you can do that one by yourself all the way through. Okay, let's see. I saw a lot of you doing this, plus 4.5, plus 4.5. And then from there, we're left with absolute value x plus 3 less than or equal to 12. From there, since there is nothing outside the absolute value and we cannot simplify this, from there we write our two inequalities. A negative, this becomes negative 12, so if we multiply times the negative, we flip the inequality. This stays x plus 3. We write our positive, 12 times the positive stays a positive, so everything is the same. X plus 3 less than or equal to 12 without the absolute value, right? Okay? From there, let's solve. This one, subtract 3, subtract 3. X is greater than or equal to negative 15. And this one, minus 3 minus 3. X is less than or equal to 9. Hands if you got that. Okay. So simplify, isolate, plot. Let's plot this. Okay. We got 0, negative 15, and 9. So let's graph first the green one. And it says x is greater than or equal to. Does it include the negative 15? Yes, because it's an equal or equal to, right? And then it says x is greater. What numbers are greater? Everything to the right. There it is. And let's graph this other one. Does it include the 9? Yes. I plot my point. X is less than that, so everything to the left. And does everybody see where they're intersecting? Yes, right here. Therefore, we know that this is a compound and it's an and. So to check, I'm going to write absolute value x plus 3 and then minus 4.5 minus 4.5 less than or equal to 7.5. Yes? And my bad. Instead of x, I'm going to open up parentheses. Thank you. Right here. So this is parentheses. Oh, all right, fine. All right, so from our solution set, which number did you use to check? 0. Okay, I'm going to use negative 3 since it's part of the solution set, right? Check this out. What is negative 3 plus 3? 0. And we're left with negative 4.5. Is that less than or equal to 7.5? Yes. And then let me write my inequality. What are my extremes? Negative 15, and this one is 9. So therefore, negative 15 is less than or equal to x, which is less than or equal to 9. And it's solution set of all real numbers x such that that. All right? Hands if you got that by yourself. Okay, not bad. All right. So now this next one, I want you to copy it on the right-hand side at the top from the very beginning. Here it goes. Copy this one, please. 3 plus absolute value x plus 2 greater than 5. 3 plus absolute value x plus 2 greater than 5. Okay, let's solve this one together. Let's see. What's outside the absolute value? It's a 3. But since the 3 is not right next to it, it's not multiplication, right? So therefore, what symbol is this? It's a positive 3. So to get rid of it, we need to subtract 3 from each side. So let's do that. Subtract 3, subtract 3. These cancel. We're left with absolute value x plus 2 greater than, what is 5 minus 3? That is 2. From there, could we simplify this side anymore? No. The absolute value by itself, and over here we can't. So from here we write our two inequalities. I'm going to do the first one, the negative in red. So let's see. 2 times the negative, that's negative 2. And we flip the inequality symbol. Yes. And we're left with x plus 2. For this side, plus. So everything stays the same. X plus 2 greater than 2. All right, let's solve. This one, subtract 2, subtract 2. X is less than negative 4. This one, subtract 2, subtract 2. X is greater than 0. So simplify, isolate. Now let's plot this. Let's plot our solution. All right, so then therefore I got 0, negative 4. I'm going to start with a green one. Does it include the negative 4? No. I circle my spot, and it says x is less than that, so everything to the left. All right. From there, 0. Does it include 0? No. I mark my spot, and x is greater than that. Everything to the right. What do you guys notice? They don't intercept, so these are a or. It became a compound, but or. Everybody with me? Okay. So let's check just to make sure that we got it. So I'm going to rewrite this. 3 plus absolute value, open parentheses, plus 2 greater than 5. All right. So let's see. What number from my solution sets would you want to substitute in there to check? Negative 2. Let's see. Negative 2 is right here. It's not a part of my solution set. 0? Is 0 part of the solution set? No, because it's open. Okay, I'll try 1. -1? No, because it's not here. I'm going to try 1. So I'm going to substitute 1 in here. So what is 1 plus 2? 3. Bring everything else down. The absolute value, the plus, the 3, the greater, the 5. What is the absolute value of 3? 3. 3 plus 3 greater than 5. What is 3 plus 3? So is 6 greater than 5? Yes. All right. So let's write our solution set. Solution set of all x such that, what is my first inequality right here? X minus -4. Or, what is my second one? X greater than 0. Pretty good. All right. Pens down really quick. Eyes up here. Let me show you something. See if you can see the pattern. Everybody look up, please. Pens down. Let me go to the beginning of this lesson. Who noticed that, everybody look up, please, that the inequality symbol from the time we started was pointing to the left? Look at the second one. Pointing to the left. Pay attention or you're going to miss it. The next one, pointing to the left. And all of these were what? And let's look at this last one. What is it pointing to? And what kind is it? So from now on, whenever you see an inequality, and if the arrow is pointing to the left, it's in and if it's pointing to the right, it's in, and if it points to the left, it's in, and if it points to the right, it's in. So let's see. If I was to give you this next one, let's see if you know what kind it is. What kind is that? Or because it's pointing to the right. The little arrow is pointing that way to the right. Okay? So don't copy that one. I want you to copy. Hold on, we're almost done. Copy these two really quick. Last thing. You can copy them side by side. So now, as you're copying, look at this. To solve this one, I add 5 to each side, and we're left with absolute value x plus 4 greater than 3. So now check this out. The solution for this one is all real numbers. We don't need to do our 2 inequalities. Why? If I was to substitute, everybody look up, if I was to substitute into this variable any number, the absolute value makes it a positive, doesn't it? Are positive numbers greater than negative numbers? So that's why it doesn't matter what number I substitute in there, it's always going to be a positive. That's why it's all real numbers. Look at the second one. Subtract 9, subtract 9. Look at this one. If a number comes out of the absolute value, say what? A positive? Are positive less than negative numbers? No. So therefore, for this one, will not have a solution. Those are 2 special cases that you just need to look out for. Okay? So homework for tonight. Page what? 181, numbers 1 through 35 odd. Turning your homework on your way out, guys. Have a good one. Enjoy your homework. See you guys tomorrow.